Now that I've finished the semi-finished toolpath, I'm going to move forward and program the finishing toolpaths. I'm going to use a 3/16 ball mill, and the nice thing about this surface finish toolpath is that the previous toolpath, the one that I'm calling semi-finish, and the actual finishing toolpath are the same type of toolpaths. And what I can do is I can copy and paste, change the tool, change a few other settings, and one of these existing toolpaths will carry over to the following finishing toolpath. So what I'm going to do is I'm going to actually select the left side semi-finished toolpath. You need to be careful when you do this. You want to select just the toolpath that you're copying. I have a green check next to just this toolpath. So right click on it, copy. Next to the insertion arrow, right click and paste. I'll expand the properties, and now I can access the parameters. So I'll go into parameters, and I'm going to go to the very top, toolpath type, finishing equals scallop. If I go back to canvas, I've got an image of the toolpath manager with the two new toolpaths added to it. And I'll scroll down, we can see some images showing us what the part will look like prior to this toolpath. And then the toolpath type. So currently I'm looking at this page inside of Mastercam, and I'm going to just work through all of these settings and make sure that they are what they need to be, make changes if I need to. So very first page, toolpath type equals scallop. We're good. I'll scroll down, model geometry. The machining geometry is going to be the same. Now we have 82 in this image, it shows 84. 82 is correct for what we are doing. So you can see that there is 0 left on the walls and 0 left on the floor. So let's go back to Mastercam. Go to model geometry. Now these values are from the previous toolpath, so I'll double click in this field, 0, enter, and then I'll double click in this field, 0, enter. That will take care of all the changes that we need to make to this page. Go back to canvas. Toolpath control. Now this will be interesting because what we're going to do is we're going to use the same boundary that the previous toolpath has used, but we need to change the compensate to. At this time, or with this tool, I do not want the center line to go beyond this edge, and the way that we drew it in originally, this edge is 100 thousandths to the right of that bottom of the base, and that is greater than the radius of the tool that we're using, so that would allow it to send the tool down to machine this face. So what we're doing is we're keeping the radius inside. The center line will still be able to pass beyond the edge of the part, but this way we don't have the tool trying to machine the bottom of the base. So back inside of Mastercam, go to toolpath control and compensate to inside. Then watch what happens to the graphic up here. So we want the tool, the full tool, to stay within the boundary that we defined. I'll go back to canvas. For the tool, we're going to use a 3/16 ball end mill. We're going to lower the cutting speed, and from here I'll go to Mastercam. I'll go to tool. We're going to need that. We will need to add that 3/16 ball end mill to our tool list. So select library tool. My filter is active. I'll select the filter icon. This time, instead of looking for a 1/4 inch ball end mill, I'm looking for a 3 divided by 1/6 or 0.1875. I'll select OK. There's one tool that fits that description. I'll double click on it, and it's added to our tool list. We're being prompted, your default workpiece material does not exist. OK. Once again, I'll select a 6061 aluminum. Once we have this tool added to our tool list, right click on the tool, select Edit Tool. I'm okay with the settings on this page. I'll select next. Set the number of flutes to 3. I'll turn the coolant on at this stage. And something I want to say about the number of flutes. This is based off of the tools that you're using. I have a 2 flute 1/4 inch flat end mill, and I have a 3 flute 3/16 flat end mill. So I'm sorry, ball end mill. I have a 2 flute 1/4 inch ball mill, and I have a 3 flute 3/16 ball mill. So that's why these values are changing. From here, I'll select finish. I'm going to set my SFM to 300. I'm going to set my feed rate, or my FPT, equal to 1% of the tool diameter, so 0.1875 times 0.01. And then I'm going to set my plunge rate to half the feed rate. So in this field, 34.38 divided by 2. And then we'll need to update the comment. I'll copy the tool name. I'll paste it over the previous tool description. I need to remove an L. And this will be finish left face. That should complete the changes that I need to make on this page. I'll go back to Canvas. We're not using stock, so we'll skip over that. The cut parameters. We're going to change our scallop height to 1/10 of a thou. This will give us a very fine surface finish. Depending on what surface finish is acceptable to you, you can adjust these values for a quicker cycle time. I'm going to set this to 0.0001. This will be a relatively long cycle time. So from here, I'll go back to cut parameters. I'm inside of Mastercam. For the scallop height, 0.0001. And what that calculates out to be is a 0.0087 step over. So that takes care of all the changes that I need to make to this page. For my steep shallow, these values will carry over. The maximum depth, this would be excessive on the overstep or the step down, or the distance that the radius travels beyond the center line of part. I want to make it slightly greater than the radius of the tool. The radius of the tool is 0.09375. So if I go to minus 0.1, that will position the tool slightly below the full radius. And this is what I want. From here, I'll go back to Canvas. I'm looking at steep shallow. We just took care of that. So you can see that the values changed to minus 0.1. The linking parameters. I don't think anything has changed here from the previous toolpath. It's always good to check, make no assumptions. This all appears to be good. And we're using the same left plane, left face plane for the WCS, the tool plane, and the construction plane. So if I come down here, all of this carries over. This looks good. So from here, I'll select OK. It'll take Mastercam a bit to process this toolpath. From here, we'll look ahead a little bit. The images above are for the finished machining of the left side of the knight. The T-plane that is referenced for the above toolpath is left face T-plane. To do the finish machining for the right side of the knight, copy the proven finish pass left face toolpath and paste it after the original toolpath. So what we're going to do is we're going to make sure that the current left face finishing toolpath is good, and then if everything checks out, we're going to copy it and make a few changes to the copied version and use it for the right side finish toolpath. So I'll go back into Mastercam. It's done processing the toolpath. So with just this toolpath selected, I'll select backplot. I'll select play. And you can see that the step over is very fine. And if you zoom in, you can see the step over, the size of the step over. This is going to leave a very fine surface finish on this part. If the surface finish is not that critical to you or that important to you, what you can do is you can increase that scallop height, and that'll cause or create that will create a larger step over, decreasing your cycle time. And you can see that the center line of the tool does overlap this edge, but it does not dip down below and try and machine this surface right here. That's why we changed the containment boundary to the inside, or keep tool inside of the containment boundary. So I like what I see here. I'll exit backplot. I'm going to copy this toolpath. Be very careful. This toolpath is the only toolpath that's selected, so right click, copy. Next to the insertion arrow, make sure that the insertion arrow is at the very end of the program. Right click and paste. I'll need to make some changes to this toolpath so that it works for the right side finishing toolpath. I'll go to parameters. I'll go up to the tool, 3/16 ball and mill, finish right face. Once again, all caps. And then I'll go down to the planes, and for the tool plane, I'm going to keep the WCS, or the working coordinate system, set to the left. This will establish A0. And then for the tool plane, this is going to change to right face. And then the construction plane, I'll change this to right face also. And what this will do is, this will tell the machine to rotate the A180 so that it can access or machine the right face of the knight. So from here I'll select OK. It's going to regenerate this toolpath. Now that it's done regenerating this toolpath, with just this toolpath selected, I'll run it in backplot. And once again, we're seeing a mirrored image of what the previous toolpath has done. And I prefer to check it in backplot before I run it and verify, just in case there's some mistakes. It takes a little bit longer to open up verify, and I find that this saves a little bit of time. So I think that this looks good. I'm going to exit backplot. I'm going to select the two new toolpaths. And before I go to verify, I want to update my stock for verify, so I'll go to simulator options. I'm going to use the stock model for my stock inside of verify, the previous stock model that we've created. And I always recommend that before you run verify, save your work. So with these two toolpaths selected, verify. Now the verified has opened. It's giving me a little, it's not responding quickly. All right. So this is what the part currently looks like. I have the 3/16 ball mill. I will increase the precision on this one. This will definitely slow down verify. And then I'll select play. And what this toolpath is doing is it's removing the 5 thousandths or 0.005 inches that we intentionally left on the part. There are a few areas that it cannot reach, and for what we're doing, or for what this video is trying to accomplish, that's alright. Like I was saying in the previous video, if you wanted to step it down, keep creating toolpaths where you're using smaller and smaller ball mills, you could get into the areas that the previous tools could not reach, and then you could focus on the finer details of this part. There will be some material left between the ears, and it still has an interesting look to it. I'm satisfied with how it looks. But like I was saying, if you wanted to, you could take it to the level where you get in there with some very small diameter ball mills and machine it to the surfaces or the exact surfaces of the part. At this time, the part is done inside of Verify, and I'm inspecting the machine part, and you can see that there is no undercutting from the previous toolpaths. This transition looks very nice. The gray area represents the region or the area that the toolpath couldn't reach with the current orientation of the rotary table. So what we'll do next is we're going to rotate the part so that the face is pointing up. We'll machine inside of here with the 3/16 ball mill, and then we'll rotate it 180 degrees from that position, and then we'll re-machine, or we'll do a finish pass in this area, focusing on this area, and we'll machine away these cut marks from the previous toolpaths. So from here, I'll exit Verify. I'll minimize the two toolpaths that we just created. We're starting to run out of room inside of our toolpath manager. I'm going to create a stock model that reflects what this toolpath or what these two toolpaths have done. Prior to that, I'm going to make this stock model, the visible stock model, invisible. So from here, insertion arrows at the very end of the toolpath group, I'll go to toolpaths, stock model. I'll call this one finish pass. Left, right. What did the stock model or part look prior to what did it look like prior to these toolpaths? So I have a stock model that shows that. So I'll go to initial stock setup, stock model, semi-finished 1/4 inch ball mill, or the stock model named semi-finished 1/4 inch ball mill. And then I'll go to source operations, and I'm going to control select the last two toolpaths that we have created. So from here, I'll select OK. Mastercam will take a moment to generate or create this stock model. You can see that it's still processing the stock model. And the next set of toolpaths that we create, we're just going to copy one of these toolpaths, make adjustments to it so that it machines the inside area. We will use a containment boundary that controls or keeps the tool within an area so that it focuses on the material that was left over from the previous toolpaths. Mastercam has completed the stock model, or completed creating the stock model that shows what these two toolpaths have done. Now it's getting more and more difficult to differentiate between the solid model that represents the part and the stock model. And that will happen as you get close to the finished machined part. So what I can do here is I can go into the level manager and make the solid model level invisible temporarily. You cannot make a active level invisible, so I'll change the active level to wireframe from solid. I'll turn off translucency, And this is what the part's currently looking like after the two toolpaths that we just created. And if I zoom in, you can see the material, or you can see the cut marks from one of the roughing toolpaths. So the next set of toolpaths that we create are going to focus on cleaning up in between the ears on the front side and in between the ears on the back side. So from here, I'll reposition my view. I'm going to make my solid model visible again. I'll go back to the toolpath manager, and in the next set of videos, or in the next set of toolpaths, we're going to create the toolpaths to finish up the part.